Hello everybody. Today we're going to be going over our 4.2 notes, which talk specifically about parallel lines. When you were in middle school, you learned a little bit about parallel lines. We're going to just go into some more detail today when we are talking about parallel lines. This is something that's really important that we do in Algebra 1, and it's something that you're going to talk about again in geometry. So let's make sure that we are focusing on what we are talking about today. And if you have any questions over these notes, that you contact your teacher to get any of your questions answered. Our learning target today is I can write equations for lines that contain a given point and are parallel to a given line. I can analyze relationships to make sense of problems. So our only vocab word here is parallel lines, and parallel lines are lines who have the blank slope but different blank blanks. These lines will blank cross. So parallel lines are actually lines who have the same slope. Parallel lines have the same slope. However, they have to have different y-intercepts. Because parallel lines have the same slope, these lines will never cross. Their rate of change is the same, so as one graph is going up and over, the other graph will also go up and over, and then they're going up and over, and this one's going up and over. So these lines will never, ever, ever cross or touch each other because they can't. That's how parallel lines work. Now, the way that you can kind of remember parallel lines is the two L's in parallel are like two parallel lines. Let's talk about determining if lines on a graph are parallel. So a lot of students like to look at graphs and say, oh, those things look parallel. However, the graphs can be given to you in such a way that they might appear visually like they're parallel, but mathematically they are not. So we can't just look at two lines and say, oh, I know for a fact those are parallel because they never cross. Or I know for a fact those lines are parallel because they look like they're parallel. That's never an acceptable justification on why lines are parallel. So the very first step that we need to do to determine if lines are parallel on a graph is to find the slope of the first line by doing rise over run. So we're still finding slope the same way. Step 2, we're going to find the slope of the second line by also doing rise over run. And then after we find the slope of both lines by doing rise over run, we are going to compare them. And if lines are parallel, then they should have the same slope. And when I say same, I mean everything about it has to be identical. They have to have the same sign and they have to be the same number. So it can't be like a -5 and a +5. Those are not considered to be the same slope. So let's take a look at the very first graph that we have. It says determine if the lines are parallel. So what I'm going to do is I am going to look at the first line, and I'm going to determine its slope by doing rise over run. I'm going to do the first one in red. So I'm grabbing a coordinate, grabbing a coordinate, grabbing a coordinate. I'm going to go from the bottom to this one right here. So I'm going to rise 2 and run 1. So my slope of line 1 will be a 2 over 1. Now I'm going to look at the slope of my second line. I'm going to go from the middle coordinate to this coordinate. I'm rising 2. I'm running 1. So my slope is also a 2 over 1. I have to compare these two. If they are the same, then my lines are parallel. And a positive 2 over 1 and another positive 2 over 1 are definitely the same. So are they parallel? Yes, they are parallel. When I look at my second problem, I'm going to grab some coordinates from this top graph. And then I'm just going to find the slope between those 2 points. So I'm rising 1 and I'm running a 1, a 2, a 3. So my slope is going to be 1/3. Now I'm going to look at my second line. I'm rising 1. I'm running 2. My slope is 1/2. So we would determine if these are equal. The answer is no, they are not equal. So are these lines parallel? No. Even though in this picture these lines are not intersecting, further off the graph where we can't see, they eventually will. I don't know if you guys can see this, but these lines are, and I'm going to draw this terribly, but I don't really care. These lines will eventually cross kind of up in that corner somewhere after a while. Okay, so that is how you have to determine if lines are parallel when you have a graph. You can't just say they look parallel, you have to find their slopes. All right, now let's talk about how to determine if lines are parallel from two equations. This is what you're going to see a lot. It says ensure that your equations are, and I'll just kind of explain this before I write it down. In order for you to know if lines are parallel without looking at a graph, you have to know what their slopes are. And unfortunately, remember that standard form doesn't give you slope. The only two equations that do give you slope are slope-intercept form and point-slope form. So if your equation is not in one of these two forms, you have to convert it to be in one of these two forms because we have to know what that value is right there. If we don't have it in slope-intercept or point-slope form, then we don't know the slope. So it says ensure your equations are in, they're either going to be in slope-intercept or point-slope form. If they are not, you're going to have to convert. Okay, so just keep that in mind. Once we determine if our lines are in the correct form, then we are going to find the slope of both lines. We are going to compare them very similarly to what we did up here. If they are the same, then your lines are parallel. So the lines have to, or the slope has to be the same for lines to be parallel. All right, so it says determine if the lines are parallel. This first problem that I have, both of my equations are in slope-intercept form, so I'm good. So what I'm going to do is I'm going to look at their slopes. And remember that your slope is the number that is located with x. If the slopes are the same, just double check their y-intercept to make sure that they are not the same. But because their slopes are the same, that's what we care about. And so yes, these lines are going to be parallel to each other. When I look at example 2, these lines are also in slope-intercept form, so I know their slope, it's right here and right here. Those are not the same. I have a 1/2, and this is technically 2/1. Those are not the same, so these lines would not be considered parallel. When I look at number 3, both of these forms are in kind of like a pseudo-standard form. So I am not going to say that this is my slope and this is my slope. That is incorrect. We do not know what our slope is unless our equation is in a form that gives a slope. So what I have to do first is actually convert both of these equations. And I'm just going to go ahead and convert them to slope-intercept form. You guys, we've been doing this since Unit 1. We move our x, that's always our first step, and then we divide by whatever's with y. This is going to leave me with, there's technically a 1 here, so this is going to be y equals 1/2 x plus 6. This is the equation that I'm looking at. There's my slope. Over here, I'm going to move my x. Then I'm going to go in here and divide by whatever is with y. And then we have to simplify this. -5/-10 is actually a positive 1/2. And then this is a -3/10. Here is my slope. Oh, those slopes are the same. That's actually good news. That's what we wanted. So because those slopes are the same, these lines are parallel. And you would never have known that had we tried to look at whatever number was with x in the beginning like we tried to do. This was a -1 and this was a 5. So had we done it that way, they would not have appeared to be parallel. But once we rearranged the equations into a form that gives us slope, we can actually see that they are parallel. Scooching on over, both of these equations are not in slope-intercept form. They are in standard form, so I'm going to convert these. I am first going to move my x. I have -5y equals -4x plus 10. Divide everything by -5. And we get y is equal to a positive 4/5 x minus 2. So here's my slope. It's a positive 4/5. Over here, I am going to subtract 5x. I have -4y equals -5x plus 2. Divide both sides by -4. We get y equals a positive 5/4 x minus 1/2. There is my slope. Although these look very similar, are they exactly the same? They are not, so these lines are not parallel. All right, and then lastly here, we have these two equations, and notice that neither of those equations have an x in them. If your equations only have one variable, those are your special Hoy and Vux equations, which we talked about in the previous lesson. So we need to figure out what these are, okay? So they're either going to be a Hoy or they're going to be a Vux. Because both of my equations are y equals, they are both horizontal lines. And all horizontal lines have the same slope. Remember that their slope is 0. And because both of them have a slope of 0, they're automatically going to be parallel to each other. So these are parallel. and we did it. That is how we determine if lines are parallel based on their slope. Remember that you do not know if lines are parallel unless you have equations in either slope-intercept or point-slope form. Okay, and then notice that I'm going through and I'm highlighting my slopes to check them out to see if they are the same. Even on this weird one down here, that's like a Hoy and a Vux. They were both Hoys. They're both horizontal. All horizontal lines have a slope of 0. Remember, that's the whole like O or 0 point of Hoy, so that those lines are going to be parallel to each other. All right, last section. This is probably the hardest section that we have when determining if lines are parallel, and this is writing equations of parallel lines. So whenever you see these examples here, we are going to be talking a lot about a point and a slope or things of that nature. When we talk about parallel lines, we are oftentimes going to already be given a line, and we are trying to find a line that is parallel to the given line. So we don't need a lot of information from that first line, so you're going to see me like scratch out a bunch of stuff as we go through this. All right, so it says use the following given information to write the desired linear equation. So number 1 says write the equation of the line that is parallel to the line y equals negative 4x plus 2 and has a y-intercept of negative 5 in slope-intercept form. So I'm supposed to be writing an equation in the form y equals mx plus b. And a lot of kids go, oh, I've already got it. That's my equation. But that's not your equation. That is an original equation, but we are trying to create an equation of a line that is parallel to this line. I don't care about that line. The only thing that I care about is the fact that I have a line that needs to be parallel to this line. So in order for us to have a line that is parallel to the given line, they have to have the same slope. So what I'm going to do is I'm going to grab the slope of this equation, and then I'm literally going to scratch out the rest of it because I don't want any other part of it. I don't want any other part of it. That is my slope. Parallel lines have to have the same slope. So the slope of my new line is going to be negative 4 because that was also the slope of my previous line. However, my new equation has to have a y-intercept of negative 5. Well, in slope-intercept form, you need your slope and your y-intercept. So I actually have enough information. My equation will be y equals negative 4x minus 5. So this line and this line are parallel lines, okay? I'm gonna, like, if I were to draw them on a graph, this would be negative 5, this would be positive 2, so my lines would look like this. That's my original line, and that is my new line. They are parallel, they just have different y-intercepts, okay? So if you're given an equation, grab what you need from it and then scratch out the rest. All right, number 2 says write the equation of a line that is parallel to the line y minus 4 equals negative 1/2 x plus 3 and goes through the point negative 5, negative 6 in point slope form. Well, point slope form, remember, is y minus y1 equals m times x minus x1. And you're saying, oh, we already have that. No, we don't. We don't want that line. We want a new line. Now, my new line has to be parallel to my original line. So we go to the original line, and the only thing I want from it is the slope. Once I have that, I literally don't want anything else. And I know I say literally a lot, but like literally, I don't want any other part of that. Just the negative 1/2, okay? Because I'm writing my equation in point slope form, I also need a point. Well, lucky for us, they give us a point. Remember that this is your x1 and this is your y1. Remember that when they get put into point slope form, that the x and y change places and they change signs. So my final equation in point slope form of a line that is parallel to the given line that goes through the point negative 5, negative 6 will be y plus 6 equals, bring down that slope that you grabbed a second ago, that negative 1/2, x plus 5. There is your equation in point slope form. Beautiful. All right, number 3, it says write the equation of a line that is parallel to the x-axis and goes through the point 7, 3. Okay. First, I need to know, what does the x-axis look like? If you look at a graph, okay, one of those axes is the x and one of those is the y. This is your x-axis, this is your y-axis. So I need a line that is parallel to the x-axis. Well, the x-axis is a horizontal line. The x-axis is a Hoy line. It's a Hoy line. So because it's a Hoy line, I need another horizontal line. Okay, horizontal lines have the equation y equals. That's literally what that says, Hoy. Okay, now if my new line has to go through the 0.73, this is going to be your x value and this is going to be your y value. I only care about the y value because my equation has to go through the y value specifically. So my equation is going to be y equals 3. It's really important that when you are given axes questions, like if it's parallel to the x-axis or parallel to the y-axis, that you draw out the axes so you can see the direction that they travel, and you'll know if it's either a Hoy question or a Vux question. But anytime you see an axis question like this, you definitely got to think to your brain Hoy and Vux because they're horizontal and vertical lines. All right, number 4, this is the one that's going to be a little bit of a pain in the tush, okay? We are trying to write the equation of a line that passes through the point -2, 3 and is parallel to x plus y equals -3 in all 3 forms. I need to write it in point slope and slope intercept and standard form. So the easiest thing to do first, we already have our point, so I know that I can easily plug this into point slope form, but what I am missing is my slope. This is not in a form that gives us slope. This is standard form, and standard form doesn't give us slope. So our first step has to be to rearrange this so that I know what my slope is. Okay, now that I'm here, I can definitely look at this and say -1 is my slope. So I'm going to be using this, and I'm going to scratch out the rest of it. Okay, I don't want any of that anymore. But what I do need is this point that I grabbed over there. So I'm going to grab this point and this slope and put both the point and the slope into point slope form first. So this will be y minus 3 equals -1 times x plus 2. As a reminder, and I know I'm going to have a bunch of arrows, I'm going to erase them here in just a minute. Remember that whatever this number is goes first and the sign changes, so it's going to look like a -3. This number goes second and the sign changes, so it's going to look like it's a +2. Erase, erase. Okay, now to write it in slope-intercept form, you can't just grab pieces of information. You actually have to convert. So what I'm going to do from here is actually rewrite this off to the side. And I'm going to convert by distributing the -1 into the parentheses. And because I'm trying to get this into slope-intercept form, my goal is for my y to be alone. And then this will be +1. So there's my equation in slope-intercept form. And then again, I've got to convert to standard form. So I'm going to write this equation over here. We've got y equals -x plus 1. Standard form, remember, is ax plus by equals c. And so now I have x plus y equals 1, and I'm done. We're going to go, and then, we got lots of arrows. I'll erase the arrows so that it helps, okay? But that's the easiest way to do this. So first thing, make sure you know your slope. Make sure you know your point. Put it in point slope form. Convert out of point slope form into slope intercept form. You've done this a bunch already, okay? Once that's done, then you're going to convert to standard form. And you can really convert either of the equations, slope intercept or point slope, into standard form. I just use the form that I most recently used. It's just easier for me, but it really doesn't matter what you choose as long as you are following the steps. Now, as a reminder, this one's not too bad, but as a reminder with standard form, you cannot have a -a value and you can't have any fractions or decimals. We didn't have that here, but you might see that later, like on your homework tonight, okay? So that is all I have for you. If you have any questions, you need to go see your teacher during their normally scheduled tutorial times, and I will see you in the next video. Bye.